In this video, we're going to talk about revenue, cost, and profit, and then we'll look at an example. Now, let's recall the following basic business relationships. The revenue is equal to the price per item times the number of items. So, for example, if you are a company that makes candy bars and you sell the candy bars for $1.50 each, well, your revenue is going to be the price per item, $1.50 times the number that you sell. So let's say you sell 10 of them, then $1.50 times 10 would be $15. Your revenue would be $15. Okay, now your costs as a business are equal to your fixed costs plus your variable costs. Now, what are fixed costs? Well, fixed costs are for things like buildings, machinery, real estate taxes, product design. Basically, the fixed cost is constant for a particular product, and it doesn't change when more items are produced. Okay, variable costs are for things like labor, materials, and shipping. The variable costs depend on the number of items made. So for example, if you're this company that makes candy bars, the more candy bars you make, the more it's going to cost you for the materials, basically the chocolate or whatever's in the candy bar, and also for things like shipping and the number of people that you need to make them. So your variable costs go up the more that you produce, more items you produce. Now finally, the last relationship is that profit is equal to revenue minus cost. Okay, revenue is how much money is coming in, and you subtract from that the costs that you have to make your product. Obviously, you want your profit to be as big as possible. Okay, now let's look at an example. We'll look at an example of a cell phone manufacturer. So suppose a cell phone manufacturer can make a cell phone for $20, and the total cost to produce 1,000,000 cell phones is $35 million. Now that might seem a little bit strange because you would think that if it costs $20 to make a cell phone, and you make 1,000,000 of them, you would think it would cost $20 million to make those cell phones, but it says that the total cost is $35 million. So what's going on? Well, the total costs include not only the cost per cell phone, but you also have these fixed costs, things like real estate taxes and so forth. Okay, so in part A, assuming that the cost function c of x is linear, find its rule, or find the formula for c of x. Now, one thing that we're given in this problem is that c of 1,000,000, okay, the cost to produce 1,000,000 cell phones is $35 million. So c of 1,000,000 is 35 million. Now we're also told that the cost function is linear. Now in the real world it would probably not be exactly a linear function, but for simplicity purposes we're going to assume that the cost function is linear. So c of x is equal to mx plus b. Now the b here is the fixed costs. Okay, notice it does not depend on x. There's no x here with the b. Okay, it doesn't depend on the number of cell phones you manufacture. mx is the variable costs. Okay, the variable costs. And for our particular problem, the m is going to be 20 because it costs $20 to produce a cell phone. So c of x is 20x plus b. Now the question is, what is b? Okay, well, we are told that c of 1,000,000 above was 35 million, but we have that c of x is equal to 20x plus b, so c of 1,000,000 should be 20 times 1,000,000 plus b. Okay, 20 times 1,000,000 plus b, but of course that would be 20 million plus b. Okay, so on the one hand we have c of 1,000,000 is 35 million. On the other hand, we have c of 1,000,000 is 20 million plus b. So what is b? Well, b is going to be 15 million. Okay, that's your fixed costs as 15 million. So our final formula for c of x is it's equal to mx plus b. Now m, remember, was 20, and the b was 15 million. Okay, so c of x is 20x plus 15 million. Okay, now what are the fixed costs? Well, we just said what that was. That's $15 million. And let's sketch the graph of the cost function. Now I've already sketched the graph here. On our x-axis down here is in millions of cell phones. So this 1 represents 1 million cell phones. The 2 represents 2 million cell phones, and so forth. And c of x, this is the cost in millions of dollars. So this right here would be $10 million, $20 million, $30 million, and so forth. So I've graphed c of x. Now remember, our formula for c of x was 20x plus 15 million. 15 million. Okay, now notice a few points on here. Let me do this in blue here. This is the point 1 comma 35. This point right here. What does that mean? Well, to produce 1 million cell phones, it costs $35 million. Right here, this point is 0 comma 15. To produce 0 cell phones, it costs $15 million. Those are your fixed costs. Okay, even if you don't produce any cell phones, you still have costs involved, 15 million. Up here, this would be 2 comma 55. Okay, to produce 2 million cell phones, your total cost would be $55 million. Now, one final thing, this formula is really only valid if x is greater than 0. You can't sell a negative number of cell phones. Okay, so actually really this piece of the graph down here to the left of the y-axis here, that's not really a realistic part of the graph. Okay, so I guess I could have begun the graph just right here and extended it up this way.